Hi everyone. Let's talk about hypothesis testing and when you get to the final stage after you've done all your calculations and now you're comparing your z-score to whatever criteria you have for accept reject. So you've done all the calculations perfectly, now you're doing your comparison. Let's make sure we have that right too. And to do your comparison correctly, you need to know if you need to do a one-sided or a one-tailed test, or a two-sided or two-tailed test. And this does make a difference, especially if you are close to the edges of your curve in terms of the extreme ends. So let's take a look at how this happens. In this little picture, we can see the graphs for a one-tailed test versus a two-tailed test. We can also see what we're comparing our z-values or z-scores against. We're comparing our z-value or z-score versus the z for some alpha value, where alpha is your criterion for accept-reject. In the sciences, alpha typically equals 0.05, so that's what I'm using. So these numbers here and down here are correct for alpha equals 0.05. If you're using a different alpha value, 0.1 or 0.01 or something else, then these values are not correct. So don't take them as gospel. They are correct for alpha equals 0.05 only. The explanation of how to use the one-tailed versus two-tailed test is true regardless of whatever alpha value you have. So let's take a look at how we do this one-tailed versus two-tailed testing. We are making the assumption in our null hypothesis that the value we're testing is somewhere in this little distribution right here. It's somewhere under this curve. If we reject that null hypothesis, we're saying it's not actually under this curve. It's under a different curve. And so where that curve is depends on the tails we're testing. If we're doing this particular one-tailed test where we're seeing that our sample value is actually less than the value we're comparing it against, we're comparing down here, and our true curve is actually over here to the left, where our real sample is. Similarly, if we're doing a one-tailed test on the right, then our actual curve is not right here where we have it set for our sample, but it's over here to the right. And so that's the real curve for our sample. So you would use a one-tailed test if you are asking if a value is less than some comparison value or greater than some comparison value. Or if you're doing a hypothesis test on two means, you are asking if one mean is greater than or less than another. You don't care about what's going on the other side. So for example, if you are concerned that a value is less than some value and you're over here instead, well, you don't really care if you're over here. You're only comparing one side. On the other hand, if you do actually care about both sides, you would use a two-tailed test. And that's when you're asking, is my value equal statistically to my comparison value? And then you do care if it's less than down here. You do care if it's greater than over here. And so that's how you're using the two-tailed test. So remember, one-tailed is less than, greater than. Two-tailed is equal or not equal to. Now that we've got that down, let's take a look at the area under the curve represented by alpha. Here, 5% of our area is shaded green right here, and that's because alpha is set to 0.05. It's 5% of the total area under the curve, which is 100% or 1. Similarly, if we've got a right tail, 5% is this green area, and the other 95% is over here. But if we have a two-tailed test and we have alpha equals 0.05 or 5%, we're comparing on both sides. So if we've got 5% on the left side and 5% on the right side, that adds up to a total of 10%, which is too high for our alpha. And that's why we use alpha over 2. So we take that area that we are considering to be outside our distribution and we chop it in half and we stick 1/2 on each side. And that's why this is alpha over 2 or 0.025 and this is another alpha over 2, and since we are on the right side, it's 0.975, which is 1 minus 0.025. That's where that 0.975 comes from. So that's how we distribute those areas under our curve. Now, we have our alpha value set. We know our scores for the alpha values, so we're all set to compare. Let's take a look at how we do those comparisons. Let's say our z-score for our sample of interest is 0.2. So that would be about right here. So if we are doing this particular test, we say, okay, 0.2 is right here, and that is inside of our distribution, our null distribution right here. And so we're okay. That's part of our null distribution. We cannot reject the null because our 0.2 is greater than 0.05, and we are only concerned if it is less than. We don't care if it's greater than. If it's greater than, null hypothesis works. If we look at our one-tailed for the right side, and we have a value again of 0.2, it's over here, we're still in our null, or right here, and we're not to the right of it. So we say, okay, again, we cannot reject the null because we're not greater than 0.95. Now, you may be saying, okay, wait a minute, you just accepted the null hypothesis up here in this one-tailed test because it was greater than 0.05, but now you're accepting because it's less than 0.95? Yep, that's how this works. It really helps if you draw a picture. So we are only concerned if that value is greater than 0.95 because we want to find out if the true distribution is over here to the right. If it's 0.2, it's sitting over here, right here, nice and happy in our null distribution, and you cannot reject that null. It's not greater than 0.95. Let's take a look at our two-tailed test. Here, we're going to have to compare it against both values. So, we have our value 0.2, and we need to see, is it between 0.025 and 0.975? Those are our limits set by our alpha value. And so 0.2 is greater than 0.25, so we're okay on the left side. And it is less than 0.975, so we're okay on the right side. 0.2, again, is in our null area, so we cannot reject the null. And that's how you do those comparisons. So be real careful when you're especially doing the one-sided or one-tailed tests that you are doing the correct comparison. And again, draw a picture. It really helps to say, okay, here's where my z0 value is, here's my rejection area. Am I actually in my rejection area? Seeing that pictorially often really simplifies that decision instead of sitting there messing around with greater than, less than signs and getting yourself turned around like that. So again, pictures are a great help for this sort of thing. So is sorting out. So when you're doing your one-tailed versus two-tailed test, it makes it a lot easier to sort out what's actually going on and whether or not you can reject the null.